Level 1. Hello world, now what? It is September, you are 18 years old, you are sitting in a beige lecture hall at the University of Illinois Urbana-Champaign, surrounded by 200 other students. Half of them have been coding since middle school. The other half have never opened a terminal. Both groups terrify you equally. The professor writes a single line on the board. You type it into your laptop. You press run. The words "Hello World" appear on the screen. You feel something shift. You are not sure if it is genius or luck. It is luck. You will figure that out later. The course is CS 101. You are learning Python. Your textbook is a Zybook that costs $89 and expires in 6 months. You learn variables, loops, conditionals, functions. You write a program to calculate your GPA. It has a bug. It tells you your GPA is -4. You spend 40 minutes fixing it. When it works, you feel like a god. You join the university coding club. Upperclassmen talk about leak code and the FAANG pipeline, and internship return offers. You nod as if you understand. You do not understand a single word. You go home and Google what FAANG means. You read for 2 hours. You feel the gulf open beneath you. Tuition at a state school runs around $12,000 per year for in-state students. At Carnegie Mellon's School of Computer Science, it is over $60,000 per year, the most expensive undergraduate program in the country. You are paying for vocabulary right now. Nobody is teaching you to speak yet. Your dormitory Wi-Fi goes down every Thursday night. You spend more time this semester debugging your internet connection than debugging your code. This is, accidentally, good practice. Around week 6, the feeling changes. You understand that knowing how to write a loop and knowing how to build anything real are separated by an enormous, terrifying distance. The class is handing you bricks. Nobody is showing you the building. Leap in Zainanaum. Level 2. It compiles. It just does not work. You are 19. You have survived data structures and algorithms. You spent 3 consecutive nights in the Granger Engineering Library before the binary search tree assignment was due. You passed, barely. You now understand recursion in the way you understand dreams. You cannot explain it to anyone, but you know it when you see it. You decide to build an app. It is going to be Instagram, but specifically for dog owners, and it is going to make you a millionaire. You open a YouTube tutorial. The tutorial is 3 years old. The library it references no longer exists. You spend 4 hours installing dependencies. You install the wrong version. You uninstall it. You install it again. Nothing works. You close the laptop and stare at the ceiling. You attend your first hackathon. It is Hack Illinois, 48 hours, fluorescent lights, energy drinks with names that sound like car models. You build something that functions for exactly 90 seconds during the demo and never runs again afterward. You get a free t-shirt. You feel more alive than you have in months. You create a GitHub profile. Your commit messages say things like fix and final v2, and please work. These will still be there in 10 years. A recruiter will see them. You will want to disappear. You apply to 20 summer internships. You hear back from 3. 1 is unpaid. 1 is at a company that makes inventory management software in suburban Columbus, Ohio. 1 ghosts you after the phone screen. You take the unpaid one. You write your first real feature, a button that exports data to a CSV file. Real users click it. Real data moves because of code you wrote. This is the first time you have made something that existed in the world beyond your laptop screen. You start reading job listings. Entry-level roles at mid-sized companies list salaries between $70,000 and $90,000 per year. This number seems fictional. You are eating dining hall pasta 4 nights a week. You start caring whether your code is good, not just whether it runs. This is the beginning of an obsession that will define the next 2 decades of your life. Level 3. They are paying me to do this. You graduated. You went through the gauntlet. You did leak code mediums at midnight for 3 months. You reversed a linked list on a whiteboard while a stranger watched your face for signs of weakness. You got an offer. You are a junior software engineer, level 3, at a real company. Your first day, someone hands you a MacBook Pro, adds you to 17 Slack channels, and assigns you a buddy who seems slightly overwhelmed to be your buddy. Your onboarding documentation was last updated in 2019. You spend your first week reading code that someone else wrote and understanding approximately 40% of it. The other 60% looks like it was written by a person who hated the person who would eventually read it. At a big tech company, Google, Meta, Amazon, a new graduate level 3 earns a base salary of roughly $120,000 to $160,000 per year. Equity vests over 4 years. A signing bonus might be $30,000. Total compensation in San Francisco can exceed $200,000. You grew up in a house where your parents made a combined $80,000 a year. You do not know what to do with this information. Your first real task is fixing a bug someone else filed. It is small, deliberately chosen so you cannot break anything important. It takes you 4 days. A senior engineer could have done it in 40 minutes. Nobody mentions this. You are grateful for the silence. You learn what code review means in practice. Someone more experienced than you reads everything you write and tells you what is wrong with it. Your first review comes back with 19 comments. You read each one twice. You fix them. You learn more from those 19 comments than from any single course you took in college. You discover on-call rotation. Every few weeks, you carry your phone everywhere and must respond within 15 minutes if a system goes down at 2 in the morning. This was not in the job description. Nothing about this was in the job description. You are in sprint planning meetings and stand-up meetings and retrospective meetings, and sometimes you are in a meeting about whether the meetings are structured correctly. The imposter syndrome at this level is clinical in its intensity. You feel certain that someone is about to walk in, review your employment file, and realize a mistake was made. This feeling will last longer than you expect. Your code ships to production for the first time. Real users touch it. Then your code ships to production and breaks something. You fix it at 11:45 at night from your kitchen table. When it is resolved, you sit in the dark for a moment and feel the specific weight of consequence. This job is real. You are real in it. Level 4. I actually know what I am doing. Sometimes. 2 years pass, then 3. You got promoted. The promotion required a document called a promotion packet, which you spent 3 weekends writing about yourself in the third person, citing specific pull requests as evidence of impact. It worked. You are now a level 4 software engineer. The difference is real. Junior engineers ask you questions now, you answer them, and the answers are usually correct. You have a domain, the payments pipeline, or the notifications infrastructure, or the data ingestion layer, and you are the person people tag in Slack when something in that domain makes a sound it should not make. Total compensation at a big tech level 4 sits between $180,000 and $250,000 per year, including equity refreshes tied to your performance rating. You live in Seattle. Your rent would have seemed fictional to the person you were at 19. You own features end to end now. You write technical specifications. You sit in design reviews and push back on proposals that will not scale. You have opinions about database schema, and you express them in Google Docs comments that spark 11-day debates. You have survived 2 company-wide refactoring initiatives that were declared urgent in the first quarter and quietly abandoned by the third. You have watched a colleague receive a performance improvement plan and understood for the first time that this profession has real consequences for real people. You know how to navigate the organization. You know who to talk to get a decision made, and you know when to ask for forgiveness rather than permission. This knowledge took years and is worth more than any technical skill you learned in school. Someone asks you to mentor a junior engineer. You say yes. You discover that teaching is a completely different skill from doing. You are good at the doing. You are not yet good at the teaching. You keep trying. Level 5. The code is the easy part. Senior engineer. This is where the job fundamentally changes. You are no longer measured primarily by the code you write. You are measured by your impact, a word that will appear in every performance review for the rest of your career. It will appear so often that you will briefly hate it, and then you will accept it the way you accept weather. You are now making architectural decisions that will shape how 6 other engineers work for the next 3 years. You are in Zoom calls with directors and vice presidents, translating between what the business wants and what is technically possible. This is a diplomatic skill. Nobody prepared you for it. Senior software engineer compensation at top-tier companies runs between $250,000 and $400,000 total annual compensation, depending on your performance rating and how your equity has appreciated. You have a financial advisor now. This still feels strange. You have made the fork-in-the-road choice, individual contributor track or engineering manager track. You chose to stay technical. This means going deeper. It means you will never stop writing code, which is the thing that made you love this work in the first place, and protecting that feels important. You are tech lead on a project. This means you are responsible for outcomes, but have no direct authority over the people producing those outcomes. You cannot tell anyone what to do. You can only make the right path so clear and well-reasoned that people choose it. This is harder than writing any algorithm you have ever written. You have written a technical design document that was reviewed by 30 engineers across 4 teams. The debate about the database schema lasted 11 days on a shared document. You made the final call. You made it at 8:15 on a Wednesday morning, sitting at your desk with a cup of coffee, and 6 months of other people's work followed from that decision. On-call at this level means being the calmest voice on a bridge call at 2 in the morning when a configuration change has taken down a service used by 40 million people. You are calm because you have seen worse. The fact that you have seen worse is itself a sobering thing to sit with. You start interviewing engineering candidates. You are now holding the door to the profession for other people. You take this seriously. You think about the person who held it for you. Level 6. My calendar is a crime scene. Staff engineer. Fewer than 15% of software engineers reach this level. You are now operating across multiple teams, sometimes across the entire engineering organization. You do not have a single team, you have a domain. Your name appears in calendar invites from people you have never met because your opinion on a particular technical decision is considered load-bearing. Staff software engineer compensation at top companies sits between $300,000 and $550,000 in total annual compensation. You have read Will Larson's book, Staff Engineer: Leadership Beyond the Management Track. Most staff engineers you know have read it. It is the closest thing this role has to a field manual. You write documents with titles like Migrating Our Monolith to Services, a 3-year plan. This document will outlast your tenure at the company. Engineers who join 2 years after you leave will read it without knowing who you are. Your thinking will shape their work. You will never know their names. You sit on the architecture review board. Your approval, or your concern, can stop or redirect a project that has already consumed 6 months of engineering effort. You exercise this power carefully. You have seen what happens when it is exercised carelessly. Your calendar on some days contains 6 to 8 hours of meetings. You do your actual thinking before 9 in the morning or after 7 at night. You have become protective of your early mornings the way a surgeon is protective of their hands. You spoke at QCon San Francisco, 300 engineers in a hotel ballroom. You talked for 40 minutes about distributed systems trade-offs you learned the hard way. Someone cited your talk in a blog post 6 months later. You read the citation on your phone on a Tuesday afternoon and felt something you could not quite name. Not pride exactly, something quieter. You have had a moment during a major incident where you were the calmest person on the call. Not because you were not worried, but because you had seen enough to know what the shape of the problem was. The junior engineers on the call heard your voice and steadied. You noticed this. It stayed with you. The craft is receding. The percentage of your week spent writing code is smaller than it has ever been. Sometimes you miss it the way you miss playing a sport you used to be very good at. You open your laptop on a Sunday afternoon and write something just for yourself, just to remember what it feels like. Level 7. I have to think about what the industry is doing. Principal engineer, distinguished engineer. These titles exist at companies large enough to need them. Google, Amazon, Meta, Microsoft, Netflix. There are fewer than 100 people at your level in your company. There are fewer than 1,000 in the world. You are a technical voice for the entire organization. Your decisions affect the company's competitive positioning, its technical debt profile across tens of millions of lines of code, its ability to attract the best engineers because its technology is respected in the industry. When you speak in a room, the room listens differently than it listened when you were 22. Total compensation at this level ranges from $500,000 to over $1 million per year, when including stock appreciation and performance bonuses. Some distinguished engineers at Google and Meta have accumulated equity worth $8 to $12 million over their careers. You think about this number rarely and carefully. You have a technical North Star, a vision for where the company's infrastructure should be in 5 years. You did not receive this vision. You built it, slowly, from a decade and a half of watching what breaks and why, what scales and what does not, what decisions made in haste create suffering for years. You have written it down. It is 40 pages. Every major engineering initiative in the company is now oriented around it. You speak at industry conferences not to represent yourself, but to represent a way of thinking about systems at scale. Other engineers, some of them very good, change their approach based on what you said. You feel the weight of this. You are involved in hiring decisions at the most senior levels. You have turned down candidates who were technically brilliant, but whose judgment you did not trust. You have advocated for candidates who were less polished, but had the instincts that matter at scale. You have been right more often than wrong. You carry the times you were wrong. You have a junior engineer on your team who reminds you of yourself at 22, curious, slightly overwhelmed, asking the right questions without knowing they are the right questions. You answer them carefully. You remember what it felt like to not know. You try to hold that memory close. Level 8, the architecture of everything. You are in your mid-40s. You are a fellow, or a distinguished engineer, at a company whose products are used by hundreds of millions of people every day. The systems you designed, or the systems shaped by decisions you made, are running right now. They are running in data centers in Virginia and Oregon and Singapore. They are running while you sleep. Your title is not important to you anymore. What matters is the question you are working on. It is always a question at this level, never a task. You are thinking about how artificial intelligence changes the economics of software development, and what that means for the engineers coming up behind you. You are thinking about it the way a civil engineer thinks about seismic codes, not because an earthquake is happening, but because it will. You have mentored engineers who are now staff engineers and principal engineers themselves. Their decisions are compounding in the world. Your influence is no longer direct, it is structural. It lives in the systems, the standards, the culture of technical rigor you helped build. You cannot fully trace it anymore. It has become part of the environment. You know things now that you could not have imagined at 18. You know that the hardest problems in software engineering are not technical, they are organizational, they are human. You know that the most important skill you developed was not the ability to write elegant code, it was the ability to communicate clearly about complex systems to people who think differently than you do. You know that every architectural decision is a bet on the future, and the future is always surprising. You know that the tools change constantly, and the principles change slowly, and the people never change at all. They are always curious and frustrated and proud and uncertain, in the same proportions in every generation. You sit in on a technical interview this morning. The candidate is 22 years old. They are nervous. They write a function on the shared screen. It has a bug. They find the bug. Their face does something when they find it. A small, involuntary brightness. You recognize that expression. You wore it once, in a beige lecture hall, when text appeared on a screen and something shifted. Somewhere right now, in a dormitory with bad Wi-Fi, someone is typing their first program. The cursor is blinking. They are about to press run.
Hey, if you made it to the end of this video, thank you. These stories take a lot of time to put together, so do me a favor and hit the subscribe button and leave a like. It means a lot. See you in the next one. Bye.